Yeah, so people wanted to investigate what happens to a function um, as the variable of the function approached a certain value. In this handout, you'll see some of the popular functions um, whose limit people wanted to investigate at a point. Like sine x over x is a very popular function. And here we have a table of values um, that tells you what might happen to sine x over x as x goes to 0 from left and from the right. Okay, so when x is approaching a value, then you want to know what happens to the function as x approaches that value from both sides of that value. So from left of 0, x goes to 0 from left. We're picking values to the left of x, like -1, -0.5, -0.1, and 0.01. And you see function is going to 1. Same thing same thing can be said when x is going to 0 from the right of 0, like 1, 0.5, 0.1, 0.01. Same values. Well, you can say that these values are the same because sine x over x is actually an odd function. Okay? Because f, for instance, f at -1 has the same value as f at 1. So they both seem to approach 1. Like 0.84, 0.95, 0.99, 0.9999. That is the investigation. So since from both sides the limit is going to 1, then the limit at 0 should also be 1. You know, when you take calculus, then you start by investigating limits numerically. Okay, so there are a bunch of examples here that I'm not interested actually in going over, really. Yeah, here is the limit of sine of 1 over x. Sine of 1 over x as x goes to 0. So they took 0.001, 0.00002, and so on. And you're not getting the same values here. Okay, so from the left, it seems to be, what is it? -1. From the other, it's 1. So if the limit is different from both sides, then the limit does not exist. Here it doesn't exist. Anyway, so let me just go down. I'll be going over how to investigate limits algebraically. I'll go over all of that. But what I want to mention here, I'm going to be doing a lot of problems. These are just notes that have been copied out of the book, really. Okay? I just want you guys to pay attention at these. Pay attention to these, what are called limit laws. All right? Limit laws or theorems. Okay? So theorem 2 for the limit laws says that the limit as x goes to a of c is c. The limit of a constant is a constant, so yeah, I know, we know. The limit of x as x goes to a is a. Yeah, whatever. I want you guys to pay attention to theorem 3. Okay? Pay attention to 3. 3 says, all right, let me actually write this down. Let me just switch my screen to my iPad here and say something about these limit laws. I'll just write it out. So give me a sec. Yeah, so there are, we have the sum law, we have the difference law, product law, all that jazz. Uh, Here are the laws, uh, which we have. I'll combine them both in one law. We have the sum and difference law, which says that the limit as x goes to a of f of x plus, or you could have minus, g of x is equal to the limit as x goes to a of f of x. If it's a plus, then you plus. If it's a minus, you do minus g of x minus the limit, plus or minus the limit as x goes to a of g of x. Okay? So, well, this is a very intuitive law. The limit of a sum is the sum of limits. But you have to be careful here because the theorem gives you an assumption. Okay? Who can tell me what the assumption is? Anybody?
That there is a limit?
Yeah. Yeah, you can't just do this. The limit here has to exist. Okay? This law is going to be true if the limit of each of those functions exists. If it doesn't, then you can't apply this law. So assume limit as x goes to a of f of x and limit as x goes to a of g of x. They both exist. Okay, then you can do something like that. Okay, so on your pretest yesterday, I saw people um, applying this law, right? But they did not pay attention to the fact that the limit of f and g don't exist. Okay? Yeah. So you have to be careful with that. The limit of f and g might not exist, but the limit of the sum or difference does exist. So I will give everybody an opportunity to actually investigate that. Or you have the product law, which says the limit as x goes to a of f of x times g of x. The only time that you can use this law is limit is if the limit exists. So the law says this is equal to the limit of f times the limit as x goes to a of g. The limit of a product is the product of limits. Okay? Yeah. So, what does this mean? You might find the limit of f of x, and the limit of f of x is 0, right? And you might find the limit of g of x, and the limit of g of x is infinity. Okay? Well, you're like, okay, so I can't take the limit. No, you can't do that. If the limit of f is 0, the limit of g is infinity, the limit might still exist. You have to be careful. You won't be able to execute this law right away. And this is something that you guys will focus a lot on in Math 8. All right? So please be careful with stuff like this. One thing I want to go over in this little handout is the squeeze theorem, which is used to some extent in calculus 2. And it says that if you have a function that's bounded by two functions, g of x is bounded by f of x, so the lower bound of f of x is of g of x is f of x, and the upper bound of g of x is h of x. This is, oh, my screen froze. Here we go. Yeah, so look, the squeeze theorem assumes this, but this doesn't have to be true all the time. Okay, it doesn't have to be true all the time. This could be true for all x near a. With x not equal to a necessarily. Okay, so not everywhere, but in the neighborhood of a. All right, g is between f and h. Okay, and the law says that if the limit as x goes to a of f of x is equal to L, and the limit as x goes to a of h is also L, okay, then since g is bounded by f and h, then the limit of g has to be L. Which is a very common sense thing. G, the limit of g is between L and L, so the limit of g is also L. If a number u is between L and L, then u has to be L. That is just common sense, correct? Yeah, so these are the limit laws. Y'all are kind of familiar with it. I do want to just go ahead and work some of the problems on the worksheet, and then we'll take a break, and I will leave the rest up to you to do, for you to do. So let me find my file. And I want to, so number one, do you guys see the day 2 limit handout? I'm not, if you guys do, I'm not sure if you guys do. Do you all have access to day 2 handout?
Yes.
Okay, so that's all, also in the modules for day 2 on Canvas. All right. So, what is the problem with taking limit? Okay, in Calculus 1 or Calculus 2, you might, well, let's look at one of the limit laws. One of the limit laws says that, so going back to the law, the limit as x goes to a of f of x divided by g of x. Okay, so if you're finding this is the limit of a quotient, limit of f, quotient of f and g. the only time that you can take this limit is if the limit of f, so you can apply the limit to the top and apply the limit. Is my screen frozen? So you can apply the limit to the top and you can apply the limit to the bottom. Okay, that's cool. Given that, first of all, the limit of f and g are not both 0. Okay, so you can do this, and this is equal to, like, let's say L1 over L2 given, so limit of f is L1, let's say, limit of g is L2, let's say, given that L1 and L2 are not both 0. Okay? Yeah. So given that L1 is not equal to 0 and L2 is not equal to 0, or L1 is not infinity and L2 is not infinity. So when this happens, we get what's called indeterminate. Have you guys heard of that before? The indeterminate case? Anybody? Who can explain what indeterminate is?
I think I'm familiar, but I don't know if my definition is correct, but it's when you cannot establish the exact value of the limit. So like if you have 0 over 0, infinity over infinity, infinity, negative infinity plus infinity, or
Right, very good. Yes, very good. So the reason 0 over 0 is called indeterminate is because we don't know what the heck it actually is. Okay? Look, someone could interpret 0 over 0 as 1. Because if you divide a number by itself, you have 1, yeah, fine. All right? But someone else could say that if you divide 0 by anything, then you get 0. 0 divided by anything is 0. Or someone could say anything divided by 0 is undefined. Right? Division by 0 is not allowed. Or someone else could say, hey, 0 over 0, the top 0 is like, let's say, 0 times 2. Right? Isn't 0 same as 0 times 2? Yes. 0 is the same as 0 times 2. Let's just say divided by 0, and then you cancel the zeros and you get 2. So what the heck is it? Is the value 1? Is it 0? Is it undefined? Is it 2? That's why we say it's indeterminate. All right? We don't know what the exact limit is. So what you need to do is investigate limits algebraically. This is, again, this is called the indeterminate case, where you guys use a certain method in calculus 2 to find the limit. It's called L'Hopital's rule. Right? So a very easy example you're all familiar with is, like, let's say the limit as x goes to 2 of x squared minus 4 divided by x minus 2. Right. when you apply 2, when you plug 2 into the function, you get on the top 4 over 4 minus 4 divided by 2 minus 2, which is 0 over 0. So that thing is indeterminate, right? So what you do is you simplify algebraically, write that as the limit as x goes to 2. The numerator, x squared minus 4, breaks down to x minus 2 times x plus 2. And the denominator is x minus 2. So look at the factor that contributes to that 0 over 0. That factor is x minus 2. Right? So we're going to cancel x minus 2's. That's the 0 over 0 factor. And you end up with the limit as x goes to 2 of x plus 2. Well, x plus 2 is just a polynomial now. You can plug 2 in there and you get 4. Okay? So in this case, 0 over 0 means 4. You know? Of course, the problems in this handout are challenging. I will do some of them, like number 2. Are you guys seeing my shared screen here or no?
Yes.
Yeah? How come I don't see it? Oh, yeah, I do see it. Okay. So look at problem. Some of these problems are challenging, man. Look at problem 2A. Limit as x goes to 4. So these problems would be like problems that you would give if you want to hire an instructional assistant. You want to challenge them, to see if they really know how to do these problems. Like this one. I bet you I'm not gonna know how to do some of these. It's gonna annoy me. Okay, so when you plug 4 in here, what is going to happen? When you plug 4, here you get 2 times 4, that's 8 plus 1, this is a 9. Okay, so you get root 9 minus 3, which is 0. In the denominator, you get root of 4 minus 2, which is 2 minus root 2. So that's also 0. This is a 0 over 0 indeterminate. We call that again indeterminate. We don't know if the limit exists, and if it does exist, we can't say right away what it is. Okay? So what do you guys propose? So look at the previous problem, right? What happened? We did some algebra so that the factor that contributes to 0 over 0 cancels out, right? You want to do the same thing here. You want to extract the factor contributing to 0 over 0 and cancel it out or get rid of it somehow. Right? Of course, these are roots. It's not like polynomials, right? So for roots, you can't factor. You do the opposite of factoring in order to find that 0 over 0 factor.
Is it rational?
You're going to say what?
Is it rationalized?
Yeah, rationalize. Multiply by the conjugate, okay? Ivan, you see the screen, but how do you have access to the handouts? Let me see if I can share the handouts for you. The handouts are on Canvas. So for anybody who doesn't have the handout yet, let me see if I can just send it to you. Day 2, give me a second. So give me a second. For those of you who can't access the handout, give me 1 second. Beta day 2, there we go. It's in the chat box. So if you click in the chat box, you'll be able to open that file. All right? Cool. Okay, so what we do here is we multiply by the conjugate, or we rationalize. We want to get rid of those square roots, and we know that really the conjugate of a plus b, the conjugate of a plus b is a minus b, correct? Yes. Yeah, conjugate.
Your screen is frozen, Professor.
Yeah, God, man, I hate that. Conjugate of root a minus root b is root a plus root b. Why is that? It's because when you multiply these out, due to the difference of two squares, yeah, so because if I do root a minus root b times root a plus root b, okay, a minus b times a plus b is simply a squared minus b squared. So here you get root a squared minus root b squared. And that gives you simply a minus b, square rootless. Okay? Yeah. So here the you have square root of x minus 2. Well, your x minus 2 is like a, and 2 is your b. So we multiply by the conjugate. Just begin by multiplying the top and bottom by that square root of x minus 2. Okay? And you get the limit as x goes to 4 of, in the denominator we have, as we saw, x minus 2 minus 2 because of the difference of two squares. And on the top, I am going to leave, that should be x plus 2. On the top, leave the x minus 2 square root plus 2. So I am writing this term first, okay? And then write the next square root group, square root of 2x plus 1 minus 3, okay? Yeah. And this is, of course, x minus 4. All right. So we do still have that, we have that 0 still in the denominator. right? And this is still going to be 0. So let me go one step further. I just want to go over a variation of what both Mitch and Aika explained. So that's the x minus 4 factor. And we have the square root of 2x plus 1 minus 3 factor. This guy. Okay, so if you now still plug 4 in, you are still going to get 0 for that. And you're still going to get 0 for that. Okay? It's still a 0 over 0 indeterminate. And no, you can't cancel these out because they're not the same factors. This guy though is not 0. Square root of x minus 2 plus 2, that is not 0. So if you plug 4 in, you get 4 minus 2. So that would be root 2 plus 2. This is not 0. So this and this factor are still 0. So you need to again multiply by another conjugate to try to see if you can get rid of that 0 over 0 situation. Okay? And to do that, multiply by the conjugate of the other two terms, which is the root 2x plus 1 minus 3 root 2x plus 1 minus 3. So every time you have a 0 over 0, okay, multiply by the conjugate of the expression that gives you the 0. Okay, so here we get the limit as x goes to 4 of root x minus 2 plus 2. So this is okay, root x minus 2 plus 2 is okay. That's not the one giving you the 0. It's that you have to multiply these two. Again, you have a minus b, a plus b. When you multiply them, you get 2x plus 1 minus 3 times 3, 9. Okay, divided by x minus 4 times the root of 2x plus 1 minus 3. All right? Yeah, so now we get root x
Excuse me,
minus,
Professor.
yes.
Isn't the conjugate plus 3? Oh, somebody's in the chat too. Isn't it? Isn't the
Plus 3.
conjugate
Yes, it is a plus 3. Yes.
Oh, okay.
Yes, that is a plus 3.
Somebody mentioned it in the chat too. So.
Yeah. So did I get my? Yes, I got that right. Yeah. Okay. I got the product right at least. All right. So over. Yeah. So there we have a 2x plus 1 minus 9 is negative 8 divided by that x minus 4 root 2x plus 1 plus 3. Okay. So yes, this factor here and x minus 4, they do actually reduce, right? You can, from this factor, you can take out a 2, you get x minus 4. Here is the factor contributing to 0 over 0. That cancels out, right? So this is gone. You can now plug 4 in, and you're no longer going to get 0 over 0. Okay, so I guess if you have an expression with square root terms on the top, square root terms in the bottom, you have to conjugate by both top and bottom, and you can conjugate by the bottom first and then the top and then simplify. All right, so yeah, challenging problem. Stuff like this does not show up in Math 8 and 11 anyway, but they're just good. Problem B is just like problem A. Let me see if I can discuss C here for you. All right, so I will do a variation of C. Let's take something like 3x plus 1 minus the root of 3x minus 1 divided by x. So when x goes to 0, this becomes indeterminate because the top becomes absolute value of 1 minus the absolute value of negative 1. That gives you 0. And then the bottom is 0. Every time you have absolute value equations, don't write you have a question, Nicole? Nicole has a question.
Oh no, that was the correct
Previous?
conjugate on the last problem.
Okay. All right. So C, I'm doing a problem a bit different than C. I'm leaving the actual problem C to you for you to do. Whenever you have absolute values, you need to acknowledge that an absolute value function is a piecewise function. It can be broken down into pieces. Okay? Again, keep in mind that this is a 0 over 0, and that is indeterminate.
So your screen is actually frozen right now.
Oh gosh, this has been happening since the beginning of times. Okay, so we break down an absolute value function. Let's do that. So just focus on that for now. We want to redefine absolute value of a function, and remember the definition of absolute value function. Let me write it down over here. Absolute value of u is piecewise. It's either positive u if u is positive, greater or equal than 0, and it's negative u if u is negative. What does that mean for many people who don't understand this definition? If, like, let's say I take u to be negative, okay? Say u is negative, say u is negative 1. Absolute value of negative 1 is equal to 1. Well, it's the opposite of actual u. 1 is the negative of negative 1. And negative 1 is our u. So it's the negative of u. So if u is negative, absolute value of u, you need to multiply it by a negative because a double negative makes it positive, right? If you think about it, this is the u axis. U, if u is positive, is this line. This is y equal to u when u is positive. And negative u is the 45-degree line from the negative x-axis. This is y equal to negative u. And that's for u negative. Okay? So you get the v function, the v graph. All right. So now let's break down these absolute value functions. Hopefully this will work. Let's go with the absolute value of 3x, 3x plus 1. Okay, this has two pieces, either 3x plus 1. Given that 3x plus 1 is positive, so if 3x plus 1 is just positive, absolute value of it is itself. It's 3x plus 1. Okay? Well, 3x plus 1 being positive means that x is greater than, move the 1 over, you get negative 1 divided by 3, negative 1/3. Okay? The other piece, absolute value of 3x plus 1 is the negative of 3x plus 1. If 3x plus 1 is negative, or if x is less than negative 1/3. You have to break the absolute value down. All right, something you do a lot for math 15 and 11, as well as 8. Okay, now let's pay attention to this limit. X is going to 0. X is going to 0. So you ask yourself, hey, where is 0? Look at the first piece. First piece is from negative 1/3. This is negative 1/3 going to infinity. So 0 is actually there, correct? 0 is greater than, 0 is here, and x is going to 0. So since 0 is for x greater than 3, 0 is greater than negative 1/3, then the first absolute value becomes just 3x plus 1. I mean, think about it. When you put 0 here, 3 times 0, 0 plus 1 is positive. So you don't need the absolute value, right? Absolute value of 3x plus 1 and 0 is a positive 1. Absolute value of positive 1 is positive 1. So you keep that function, okay? Now let's look at the other piece, which is, or the other absolute value, which is the absolute value of 3x minus 1. There are two pieces. It's 3x minus 1 if 3x minus 1 is positive, or if x is less than 1/3, because when you move the 1 over, you get negative 1/3, I meant to say. Yeah, move the negative 1 over, you get positive 1. Divide by negative 3, the sign switches. And it's a negative of 3x plus 1 if negative of 3x minus 1 if 3x minus 1. So wait a minute. I don't know how, hold on a second. Give me a second, let me fix the first, what happened here. Let me fix the first one. Yeah, so the first one should say if 3x minus 1 is positive, which means x is greater than, I'm sorry, I gotta fix that. Yeah, so if x is greater than 1/3, yeah, that's the thing. Okay, and then negative of 3x minus 1, if 3x minus 1 is negative, which means x has to be less than 1/3, correct? So my question for you guys, since limit of x is going to 0, which interval are we in? Is it greater than 1/3 or less than 1/3? Less than 1/3, right? Yeah, so this is the less than 1/3. And again, 0 is less than 1/3 and 0 is here. Okay? So we are dealing with this interval. So this is the piece that we are going to be taking. Okay? So going back to the function, we found the first piece minus, okay, minus the negative of. So we are taking this piece, negative of 3x minus 1. So that simplifies the top over x. Okay, again, if you guys have a question, let me know. All right, now simplify. Okay, so here we have a 3x. Let me zoom in. We have a 3x minus a negative 3x, which is a positive 6x. And we have 1 minus negative 1. Right? Negative, negative, negative is negative. Okay, so you have 1 minus 1, which is 2. Is that right? Is that right here? 1, yeah, 1 minus, did that come out right? So 1, yes, yes. So you have one more time, 1 minus 1 is what? 0, correct?
Yes.
Over x. I hope that makes sense. So this one and that one cancels out, and you get basically the limit as x goes to 0 of 6, and that limit is equal to 6 because these x's cancel out. All right, so the limit of this function is actually 6. Any questions about this? Breaking out the absolute values just takes, that might take a bit of time. Okay, so that was question 2C. All right, very good, thank you, Ingrid. Question D, I will give you guys a hint to question D, because D is just such a repetition of stuff from Math 7. Yeah, I for 1 second, I thought I paused recording. Okay, so D, I'll tell you how to approach D, because we have a little time. And x here is going to -3 actually. So this will again give you a 0 over 0. All right, if you plug in, multiply, this is a complex fraction, multiply by the common denominator of those little denominators, which is 3x. Yeah, here are the smaller denominators. Common denominator is 3x. So just just multiply top and bottom by 3x, and you'll be able to reduce the expression before taking a limit. The 0 over 0 thing will cancel out. Okay, so that's how you do that. Let me see what comes next here. Yeah, number 3, I'll give you guys a hint. Number 3a, you all should be able to do. Okay, so 3a, we have the limit as x goes to actually 3/2. They say 1.5. I'm gonna change it to 3/2 of 2x squared minus 3x over absolute 2x minus 3. You know, you sometimes people when they're taking calculus, they just love calculus. People tend to love the idea of derivatives and limits and integrals. They understand it perfectly, but when it comes to algebra, they're like, oh, F it, I don't want to take this class anymore. I hate calculus. Here's a problem. This problem. You're like, well, you know what? If I can factor this x out, if I could factor the x out, well, what happened here? Factor the x out, then I on the top get 2x minus 3 with the x out. And that cancels the 2x minus 3 in the bottom. But no, there's absolute value sign there. So you can't do that. Absolute value, again, is a piecewise function. Break it down. Break it down. Let's break that thing down, okay? So absolute 2x minus 3, again, in piecewise form, it is just 2x minus 3 if 2x minus 3 is positive, okay? Or if x is greater than 3/2. And absolute 2x minus 3 is the negative of 2x minus 3 if 2x minus 3 is negative, or if x is less than 3/2. So we have, look, we have the point, this piecewise function changes at 3/2. For x greater than 3/2, you have one piece. For less than 3/2 or 1.5, you have a different piece, right? Yeah. So if you have, now let me do this. The actual function happens to be, and let me actually use some colors here. 2x squared minus 3x. So take this and make this the denominator of 2x squared minus 3. Okay, so because I have this function 2x squared minus 3x, yeah. Okay, so these become the denominator of the function. So put a 2x squared minus 3x on the top. Okay, so this piecewise function turns out to be, right? Yeah, look, the top, you factor the x out, you get x times 2x minus 3. So you know what? Let me just make the top x times 2x minus 3. It's easier to look at it that way. So I redefined the piecewise function, and I wrote the numerator in green there. Do the cancellation. That feels great, right? So our piecewise function turns into be just x if x is positive, if x is greater than 3/2, and the negative of x if x is less than 3/2. Hmm? So instead of taking the limit of this function, you take the limit of this function. That this function breaks into this. Very simple, just basically the absolute value function. That's shifted 3/2 units to the right. Okay?
Yeah,
So,
Professor.
yeah,
Yeah,
question?
sorry, I have a question. I actually don't know if it's right, if what I'm thinking is right, but you know, on the second part of the piecewise function, you have a 2x minus 3 on the numerator and also 2x minus 3 or negative 2x minus 3 on the denominator. Yeah.
Yeah.
Would it be the case that since we're also considering if 2x minus 3 is less than 0, then wouldn't those negatives cancel out? Or is it not? Oh no, only because there's an absolute value in the denominator, right?
Yeah, the top is positive. The top is
Okay, gotcha.
positive. Yeah,
All right, never mind.
the bottom is absolute value.
All right, just checking. Thank you.
Yeah. So going back to that, all we just did is break the function down. Okay. So now we are gonna go back to the original problem, which is asking to find the limit as x goes to 3/2 of 2x squared minus 3x over absolute 2x minus 3. In order to find the limit of a piecewise function, you need to find the limit from left and right of 3/2. So we do the limit as x goes to 3/2 from the right. Well, the right of 3/2 is when x is greater, right? Greater than 3/2. And the function, right? The function is just x on the right of 3/2. And we also need to find the limit as x goes to 3/2 from the left of 3/2. And from the left of 3/2, our function is just negative x. And guess what? These both give you different values. One is 3/2, and the other is negative 3/2. So this limit, what is the limit, you guys? Let me hear it.
Doesn't exist.
It doesn't exist. It's not. Yeah, so it doesn't exist. Yeah, problem 3b multiplied by the conjugate. You guys can do that. How much time do we have? I think we're doing good on time. Problem 4 is a squeeze theorem problem. Honestly, the squeeze theorem problems here are not that bad at all. I'll just do one for you. Problem 4. Yes, what do I do? Like A, maybe. It says find the limit as x goes to 0, and it's a double-sided limit. It doesn't say left of 0, right of 0, of x squared cosine of 1/x. Okay. Yeah, and what do we know about cosine? Cosine is a bounded function. And cosine x squared, cosine 1/x, it's bounded. cosine of 1 over x, if you actually graph cosine of 1 over x at 0, it's going to behave erratically. The limit is going to jump from -1 to 1 very close to 0. That limit doesn't actually exist. It doesn't. Okay? And look, this proves to you guys that I can't use the limit laws. Remember, I mentioned that. I can't say that this is the limit of x squared times the limit of cosine of 1 over x. I can't use this property because the limit of a product property says that the limits should exist. Sure, this thing is 0, right? But this thing is not 0. This thing does not exist. This limit is a DNE. It doesn't exist. Cosine of 1 over, what's cosine of 1 over 0, huh? Yeah, so you can't take the limit of x squared, limit of cosine of 1 over x, and multiply out, because the rule for product says that the limit of a product is the product of limit if the limit of each exists. So for this problem, whenever you got a cosine involved and something else, you want to use the squeeze theorem, all right? But what do we know about cosine of 1 over x? It doesn't, look you guys, it doesn't matter what is inside the cosine. Cosine, okay, so fine. You know, like let's take a right-handed limit. Let's do it, okay? Cosine as x goes to 0 from the right, let's just say, of 1 over x, that's equal to infinity, right? It's infinity, huh? Sure, okay? So as x goes to 0 from the right, cosine of 1 over x is, well, cosine of infinity is it's anything from -1 to 1. It oscillates from -1 to 1 as x goes to infinity. So this is either, it's a number between -1 and 1. Right, so it's still bounded function. Okay, fine. All right, so what you need to do is the squeeze theorem. What you say is cosine of 1 over x, we don't care about it. It's bounded from -1 to 1, right? Therefore, x squared cosine of 1 over x, multiply this inequality by x squared, you get -x squared and positive x squared. And you don't need to worry about switching the direction of those inequalities. And then you use the squeeze theorem. So you say here that the limit as x goes to 0 of -x squared, well, that's a polynomial, that limit is 0, and the limit as x goes to 0 of positive x squared, the right bound is also 0, and by the squeeze theorem, the limit of the sandwich function has to also equal to 0, correct? It has to be 0 also. Yeah, so that's how you nail those problems. I have a few minutes left. Let me, oh, for problem 5, we have root x 1 plus sine squared. I frankly did not look at these problems last night, but whatever. This function, so let's bound this function also. Look, you guys, if you have sine squared theta, it's bounded between 0 and 1. okay? Because it's a square. Sine theta is between -1 and 1. Sine squared, anything from -1 to 0 goes to 0 and 1. So it's between 0 and 1. So sine square of 2 pi over x is also between 0 and 1. If you add 1 to it, it's going to bound between 1 and 2. Okay? So all you have to do is multiply everything by root x. Same deal. Okay? And you get square root of 1 plus sine square of that bounded between root x and 2 root x. Okay? Yeah, so think about that on your own. Let me see what's next. Oh my God, there are just so many problems here. Phew. Okay, so let me talk a bit about problem 6. Problem 6, A and B, is about conjugation. You conjugate, you multiply by conjugate. Let me talk a bit about problem 7 and do something like number 7. I don't know what the heck to pick. So like let's say we have the limit as x goes to, I don't know, like let's say -infinity of, I don't know, maybe 5x plus 2, okay, divided by 10x squared plus x. I'm just making stuff up. Okay, so look, when you plug infinity in, by the way, we don't plug infinity in. Infinity is not a, let me tell you guys, for those of you who have to take my class, my Math 8 class in the future, I will tell you right now, I don't want to see you guys plugging infinity into an expression. So if you do, I swear, there are people in my Math 8 class, they say something is equal to 1 divided by infinity, and that's equal to 0. And that just, I want to take a pair of forks and stick them into my eyes. Because infinity is not a number that you can plug into an expression. Do not plug infinity in, please. Okay? It's not a number. Anyway, so you ask yourself, what's happening to the top? To the top. Top goes to infinity. The bottom also goes to infinity, right? Infinity squared plus infinity. So this is infinity over infinity case. If you have infinity over infinity, the answer, look, infinity over infinity could be 1, I don't know. Or you could say infinity over infinity. The top infinity could be 2 times infinity, because 2 times infinity is still infinity over infinity. These infinities cancel, you get 2. So which one is it? Is it 1? Is it 2? Is it 0? If the top infinity is much bigger than the bottom infinity, the answer could be infinity. We don't know. Okay? So with these problems, you want to factor out the leading term. Factor out the leading term. That is the trick. Okay? On the numerator, you guys, factor out the leading x. The leading x. On the top, the leading x is just x. You have, so if this was like a 5x squared, I would factor x squared out. The leading x is just x. So take x out. You have 5 plus 2 over x. Within the square root, x squared is the leading. So take the x squared out. You get 10 plus x over x squared. Simplify the heck out of this thing. So the top is just x times 5 plus 2 over x. Now the bottom, you have that square root of, I have the square root of x squared right here. Okay? Square root of x squared, y'all. I hate to break it to you every time. Square root of x squared is not x. It is absolute value of x. I mean, you all know this from kindergarten. Remember, if you have a quadratic equation, x squared equal to 4, square root it. Square root of x squared is absolute value of x is equal to 2. Absolute value of x means plus or minus x equal to 2. So you get two solutions, x equal to plus or minus 2. You learned this in kindergarten, I think, literally. Okay? But they say x is equal to plus or minus 2 without showing all those intermediate steps. But the reason it's plus or minus 2 is because square root of x squared is x. Unless x is positive, it is x. Anyway, so we are talking now about the square root of this x squared. And that is absolute value of x. Okay? And the rest leave alone. 10 plus. Here you have x over x squared, which is just 1 over x. Okay. Now, next step. Do not cancel this 2. You have x over absolute x. No, 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 you don't cancel that. Because absolute value of x is piecewise. It is piecewise. It's either x, if x is positive, and it's negative x, if x is negative. I'm not including 0 here because x is in the denominator and x can't be 0. Okay, so who can tell me for this absolute value of x, which of these do I take? Do I take the positive x or do I take the negative x?
The negative one, because x is going towards negative infinity.
That's exactly correct. You take the negative x because x is less than 0. Since x is less than 0, we need to take the negative x. Okay, so that becomes the limit as x goes to negative infinity of x times 5 plus 2 over x. Absolute value of x becomes negative x, as you just said, times the root of 10 plus 1 over x. Gladly now cancel the absolute x, cancel the x's. So the simplified expression is now 5 plus 2 over x times the root of 10 plus 1 over x. Now you take limit, the limit as x goes to infinity of 1 over x to any positive power is 0. So that goes to 0, this goes to 0. And you end up with 5 over root 10. And you want to rationalize that, be my guest. That's so multiply top and bottom by root 10. And that gives you root 10 over 2. That is the limit. So be careful with these problems, please. Okay?
Oh, I'm sorry, Professor. Did we need to
Yeah.
keep the negative on the denominator for?
Did my negative go away? Did I kill my negative? Oh no, I killed my negative for sure. Yes, negative. Negative. Yeah. Okay, cool. Let's take about a 15-minute break, maybe a bit less. Come back. I will put you guys in breakout room and have you guys work on the rest of the problems. Okay. All right. So
Thank you,
please take a
Professor.
break now. Hey, Mitch.
Hey, how's it going?
Mitch.
Yeah, can you hear me right now?
Yeah, how did your group go yesterday? Were people asking you questions or were you doing stuff on your own?
Yeah, so actually what happened is, I did find a couple questions, but then after the questions, then we also discussed them for a bit, and then after, but it was, I was there if they needed anything clarified, and it was really good. I thought it's good that they're